Hi there, I'm Clemover. Today I'd like to talk a little bit more about microcontroller and the bus size that you can see in them. Although if you were born in the 90s or a little bit before, you certainly heard about the number of bits in video game consoles, for example, or even more recently in computers where we had two different types of computers, the one running on 32 bits and the one running on 64 bits. Nowadays they all seem to have switched to 64 bits, but what happened and how come now 64 bit is standard for computers, but in microcontroller you can get them from 8 bits, even sometimes smaller if I remember well, to up to 64 if you want. What does it change? It's not that going from 32-bit to 64-bit is gonna double the power of your microcontroller, but it's not useless either. Let's talk about a little bit about what it changes. First of all, what is it? That number of bits. That's gonna be the size of the operand that you can use inside of your ALU. The ALU is gonna be the thing doing the calculation, your addition, subtraction, and so on inside of the processor of the microcontroller. That size of operand is going to actually determine how big of a number you can handle. For example, an 8-bit microcontroller is going to be able to do additions between two 8-bit numbers. That means that you can do addition to up to 255 plus 255, and that's it. If you want to do 500 plus 500, you're going to have to do some math, some programming, some C library to do it for you seemingly. But that means that in the processor it's going to be cut in many operations. If you got a 16-bit microcontroller, your addition of 500 plus 500 is going to be easy to do in one operation, nothing weird happening. So all of those changes are going to be actually implicit. That's not going to change anything to your code mostly. It's going to be the compiler that's going to figure out how to handle that for you. Now, that's going to change actually many things. You're going to be able to do additions and subtraction and so on between bigger numbers, but that means that the registers of your microcontroller are going to be of that size, bigger or smaller, which means that you're going to be able to address, because those registers are going to contain the addresses of memory that you can access to. And that one was one of the biggest changes on laptops when we switched from 32 to 64 bits. That address size is the main reason why on 32-bit computers we were able only to get to up to 4 GB of RAM, because 2 to the power of 32 ends up being 4 GB. So that's one thing, memory allocation, and up to where can we go? That means that an 8-bit microcontroller is not going to be able to handle crazy big memories, for example, no matter how much you give it. And I think that's it. We're gonna have those number of bits that are gonna be defining the size of our operands. That is also gonna define the size of our registers, which is gonna define the size of our memory slots and also of our address slots, which all in turns define how big of a memory we can address. One small number that actually makes a difference in many spots, but it's not gonna simply double the power or anything. It's not gonna do calculation faster, it's just gonna be able to do bigger calculation. I think that's it. See you. The chicken. Why did the chicken eat the worm? I don't know.